All right, suppose I have the square root of something weird, like, I don't know, let's say 4.1, right? And so I want to know what is the square root. So I don't know that. What do I know? I know that that the square root of 4 is 2, right? And so I know that much. Okay. So let f of x equal the square root of x, right? So that's kind of the function that we're dealing with here. Okay, so that obviously we could take a derivative of this and we'd get f prime of x. Okay, and that's equal to, and then I'm going to switch my notation on you, right? I'm going to call it 1/2 x to the negative 1/2. Okay? And so let's put an x to the 1/2 up here. Okay, so I can take a derivative of this and I get this, right? Okay, so let's look at Euler's method, right? And what does Euler's method say? Well, Euler's method says this, right? It's like, okay, so it can be y of n plus 1 equals y sub n plus h times f prime of x. Okay, that's basically what Euler's method says. Okay, so let's go back to our situation here. The square root of 4.1. Well, I would sure like to know that. So here, let's let h equal 0.1, right? So to get from 4 to 4.1, I would add h. Okay, so now we're in business. See, the next one, the square root of 4.1. So we're using this formula, so let's move this down. Okay, is equal to the square root of 4, right? That's the old one. Plus 0.1 times f prime of x, which happens to be 1/2 and then x to the negative half. So it'll be the square root of 4 down here, okay? So let's put us the square root of 4 down there. Okay, so let's go compute this sucker, right? We could do this. So the square root of 4 is 2 plus 0.1 times what? It looks like times 1 and then 2 and 2. So that's going to be 1/4. And hey, let's get all fraction happy here. 0.1 happens to be 1/10, doesn't it? Okay, so here's our situation here. I've got 2 plus and then 1/10 times 1/4, which is going to be 1/40th. And so this happens to be 2 and 1/40th. Look how like specific I am here. Okay, so we've got that, and then we can actually go see what our error is. You know, this isn't actually equals, right? It's like, because we're using a method here, it's like kind of equals 2. So this kind of equals 2 and 1/40th. Let's go check our accuracy here. So what do you want to use? I got a lot of stuff going on in my world. 2 plus 1/40th. Okay, so there's our number, right? So that's going to be our number. Hey, let's go back there. Okay. And the real, right, drum roll everybody, the real solution is what? So let's go grab this. And it's going to be, so now I want the square root. Oh my gosh. So now I have to do 4.1 and then I push the square root button. Oh, no, I don't. Who uses reverse logic? Okay, 4.1, there you go. And the real answer is this. Oh, don't do it, don't do it. You're ruining it. Okay, that's gonna be that. Oh, man. Okay, so it's not perfect, right? Here, let's truncate that. Well, okay, so we got the 2, the 4, but you know, we're off at the third decimal. All right, but that's not bad in one step. You see what I did here? So, so that's how you can use the Euler's method on a square root. This is a critical idea here. This means that I can step forward in processes. So this is a big deal. It's not just this. This is think about oil and gas or anywhere that you're trying to step forward and look at stuff. Okay.